Hey guys, today I want to show you how you can use AWS Cloud Development Kit to create applications on AWS using Lambda and TypeScript. And I want to show you some patterns that we came up with that should simplify the workflow. Um, so let's jump right to it. Okay, so I have an empty directory now, and um, we'll be creating monorepo here. So first, I'll create a standard package JSON. We'll be building a small calculator app. The only thing to keep in mind here is that we added workspaces section where we define the packages. Um, this is for Lerna, um, and the rest is pretty generic. I like to work with ESLint and Prettier whenever I can, so that's why there's so many dependencies here. If you don't want to use ESLint, obviously you can just remove all this here, and then we also need a generic TypeScript configuration. Nothing crazy here. We just say to include the code in the packages. The third part is Lerna. So again, we point to where the packages will be. We also say that we're going to use Yarn for our NPM client and that we use workspaces. Version dependent, we probably don't even need that because Lerna will not be changing versions here. Then let's add the generic git ignore file and ESLint configuration. Again, do whatever you want here. I will not be going through this particular setup. So that's really the setup for a monorepo. And now we need the packages folder, and we'll be creating two AWS Lambda functions here. One would be add. Since this is a separate package, we also want a package JSON here, and we'll scope it to the calculator scope. So we'll say calculator add. We'll do the same here. So we say add, let's say multiply. Oops. I mean packages multiply handler package JSON. All right. Now let's implement our handler for adding. So one thing I like to do is I like to use this AWS Lambda package with types, which will give me some safety net when I'm developing the handler part of my function. To use that, I need to add dev dependency that has those types in. So that's what I'm gonna do here. And let's run yarn. And this should already set up the whole monorepo for me. Yep. So even though I had the types AWS Lambda defined here, they are gonna be moved to the top level right here, top level node modules. All right. So we also want the same thing to be available in our multiply. So here, I want to have some kind of a response with a result that's type of a number. And then I say export handler. We use API gateway proxy handler version 2 with that response. And that will verify that what we return from this function matches this type. And yeah, and another thing that it does is like it adds the event here and the context in our case we don't use the context, but it's also always nice to have those things typed. So we'll only use event in this case, and we basically want to return an object matching this type. So we want to have a result, and then we want to say that we want to parse in the event query string parameters. So this is already great. Like usually you wouldn't have those things show up, and then figuring out the shape of this event object is a nightmare. That's very easy to make a mistake. Um, so let's say we will want to have two arguments here, A and B. So since we are adding here, we basically want to do the same, and then for B. That's basically it. We'll repeat it for the multiply. The only difference here will be that we are multiplying. Okay, so we now have two functions ready, and now we need a way to deploy. So let's do that. So we'll create another package called CDK, and we need the package JSON here. So again, pretty generic. There are some dependencies here that are pure dependencies of the cdk-typescript tooling that I want to demo for you guys here. Actually, we don't need to use alpha anymore. Then yeah, and that should be enough. We want a generic TypeScript config that basically extends our main TypeScript configuration. Then there is CDK JSON, which again you can read on AWS what those things do. When you create an app using the CDK CLI, it adds some of those things automatically for you. One thing that we do differently than what AWS documentation tells you is that we use TS Node to run TypeScript code directly. What they would show you is like they would want to have something like this, like node build and then cdk.js, and then they would like in their tutorial they create a watcher that watches the TypeScript code and it keeps compiling JavaScript code. I think that's an unnecessary step, and it's easy to forget to run the watcher, and just more moving parts. So I definitely prefer to just compile the code runtime basically, so you don't have to remember to do anything else. Right. So now we need to create that src cdkts first. Let's add some generic git ignore, and then the typical pattern for the CDK is to have this CDK entry point, and that's going to be very small actually. So first of all, since this is executable, we'll add a shebang here, and then we want to have basically what we need to do here is we want to have a new application, and for that we need to import CDK from the AWS CDK core. We need the dependencies installed. So once again, just run yarn in the tab directory. It will install dependencies for all the packages. All right. It should know. Yep, it understands what's going on there now. So we create an app, and then you want to create our calculator construct, which will pass the app, and then the base stack name. In our case, we just call it calculator. Obviously, the calculator doesn't exist, so let's create it. And actually, let's move it to a new file. Okay, nice. So this is imported now. And the calculator stack needs to extend AWS CDK stack. So let's do that. And we will import it from, we also need the app. So stack app from AWS CDK core. And then in the constructor, we need to call the, oh, that's not the calculator. That's a stack name or ID. In our case, it's a stack name. So we call this the constructor of the stack. And then we want to do two things here. So we want to add service, and we want to create multiply service. We'll pass this to both of them because they will need the context to actually create resources. So I'm going to create a function now. That's not this. We want the stack here. Oops. So stack. And we'll basically do new TypeScript function. This is using the cdk-typescript tooling. We set, we pass stack to it. We add a function name or just a name for the resource or construct. And then we set up some props. So in our case, we want to say that we want the calculator add. Oh, actually, let's put it in source. Both of those. Like our TypeScript configuration is concerned about the TypeScript code that's inside the packages src, so I had to move it. Okay, let's take a look at the calculator. So we say calculator add and then src handler ts, and WebStorm will tell you that this is correct, which is very nice. The problem though is that we don't actually want to require this code here and have it assign to this entry property. We want to assign a path to it. So we do require resolve. The reason why I start with require is that for resolve, there is no, so far now at least, checks whether this path is correct, and WebStorm doesn't help you here. So I like to start with require and switch to resolve. Yeah, and then we want to expose this TypeScript function. So we would do add service API, and we do API gateway 2, which we need to import. We need to import, and then from it we need to call HTTP API. We pass stack to it as always. This is add service HTTP API, and then we have default integration, and then there's another thing that we need to import. So this is API gateway to integrations, and we do Lambda proxy integration, and to it we basically want to pass the handler like this. Well, we don't have the handler yet, so like that. And then when we deploy, you want to see the URL for this function. So we also create CFN output stack, the URL, and the value of it will be the add service API URL. And we'll do the same for multiply service. Copy paste. So the multiply multiply here as well. Um, yeah, and now if I go to the CDK, packages CDK, I should be able to just do yarn CDK deploy. So now the Webpack compiled the code for those two functions, and the CloudFormation stack is getting created. Takes a little bit, especially a little bit of time, especially the first time around. Um, but even the subsequent deployments are actually not uh, fast enough to provide a nice development experience. So we'll show you in the next video how you can speed this up. For now, let's just wait. All right, so it got deployed, and now we can call those functions to check. So A, let's do 2, and B, 4. So we'll get different results for multiplying and addition. So that looks like a correct answer for adding. Now let's try multiplying. Okay, cool, that works. And now the next thing that we want to do here is that, as you can see, there is quite a bit of a repetition here. And if you have a bunch of small Lambda functions, you probably don't want to do that. So with the CDK TypeScript tooling, you can just say with HTTP and set it to true. And then these two things are just going to happen for you automatically. You also don't need the handler. So at this point, it almost feels like we don't actually need separate functions. And if we were to just keep all this stuff in this one file, then I guess I would agree. Just move it to the constructor here. But what we like to do is we have this pattern where we basically like create other files where we create things that are connected together. So if the multiply service needed a DynamoDB table and maybe S3 bucket, and maybe another Lambda function, then I would have them all defined in one function, and that function would be in a separate file. Otherwise, this would just grow to a huge size very quickly. So yeah, if you have just a few things, then yeah, put them here. But just keep in mind that once things grow, it's nice to be able to group them together. So oops, let's see. Let's deploy this again and verify that it still works. So meanwhile, let's talk a little bit about what the CDK TypeScript tooling is doing here for the TypeScript function. Obviously, AWS Lambda will not run TypeScript code, so it has to be transpiled first. And the pattern that AWS shows you is obviously to just transpile the TypeScript file into JavaScript file and use that, and that works great. And that would even work great in our case because our functions are very small and they don't have any dependencies. This is just a type dependency, so this actually gets stripped out. But the moment you start adding dependencies, and either it's an external dependency from node modules, or whether you want to have some shared library or libraries in your monorepo that you reuse between your functions, then you cannot just transpile one file. You need to have all those dependencies there, and then the process becomes painful. Uh, you could manually set up Webpack and basically do what the same thing we are doing here, but you don't want to mess with Webpack configuration, and you don't want to have separate configurations for all your Lambda functions. And I think it's much nicer to be able to just say, hey, this is where my TypeScript file is, and just do whatever you need to deploy it. And actually using the TypeScript function from our TypeScript tooling will also enable you to do a few other cool things that we'll show you later in a separate video or videos. Also, just you can read the documentation of CDK TypeScript tooling, and it will be obvious what I'm talking about here. Anyway, so it looks like it deployed. Unfortunately, it changed the URLs. That's because internally the TypeScript function uh, used a different ID for the HTTP API. Uh, but it should work exactly the same way, and it will not keep changing the names from now moving forward. So just verify this one as well. Cool. All right. So that's it for the first part of the CDK TypeScript tooling showcase. Um, Keep in mind this is a POC. This works for us. Um, you are more than welcome to take a look at the code of the tool, and I mean you probably should do that anyway, to verify what we are doing and that we are not doing anything uh, harmful, like we are not exposing anything from your CDK and anything like that. Um, and yeah, just you're more than welcome to just take this and create your own. Um, and I hope we will find this useful. One thing to keep in mind with CDK is that CDK is very finicky about different versions of its dependencies. So yeah, make sure that you set them to the same version everywhere. Otherwise, you'll get weird type errors when you try to run the code. Um, and that that's also one of the reasons why we have some dependencies here now that we don't use, like AWS logs and AWS logs destinations. That's because the tooling actually uses them, and if they are not installed it will fail. But we cannot have them as dependencies in CDK TypeScript tooling, because if they get different version, then things will just not work together nicely. I wish AWS did it did it all differently, and that things were more compatible between versions, but it is what it is. All right. Please let us know what you guys think and if you find this useful. And I'll see you soon. Bye bye.